Hi, Rob here from Handmade Extreme. If you're new to the workshop and you're looking at getting into metalwork, then you need to keep watching this video because I'm going to go through what I think are the basic essential tools to get you started working in metal and plastic. So let's get on with it. So we've got a few of the basics here that you might need for a metalworking project, and we'll try and work through them in the order that you might use them. And we'll start at the beginning. It's not the most glamorous, but measuring and marking is usually the first thing you do. And as the old saying goes, measure twice, cut once. So you've got your piece of plastic or your piece of metal and you want to cut a shape out of it. So the first thing you need to do is put some layout lines on it so that you know where to cut. So we'll start over here, and I've got some permanent markers. These are great for, if you're working with metal particularly, you can colour in the piece of metal with the big thick marker pen and then use a scriber like one of these. There's a couple here, I'll talk you through these in a second, and you can scratch a line in the ink and it gives you a nice high contrast silver line against a black background. It's a little bit easier to see than just scratching the line onto the piece of metal itself. Or, if depending on how accurate you need to be, if you need slightly less accuracy than that, which to be fair, a lot of jobs you can get away with this, you can get these super fine point felt tip pens, permanent markers. They're very popular for sort of inking in drawings and things like that. And you could just use that to mark out. They're really good, to be honest, for general work if you don't need super accuracy. But let's just assume you've coloured in your background for a second with the thick marker pen, and you're using the scribe. Now I've got 3 scribes here. This is probably the one I'd recommend for the beginner. You've got 2 ends, straight end and a hooked end. The straight end, to be honest, is the one you use most of the time, but the hooked end comes in really handy if you need to sort of trace around something, if you've got an awkward feature that you want to get around. That just gives you a little bit more flexibility. We've also just got here a jeweler's screwdriver with the end ground to a point. Works really well, it's nice and simple, doesn't really cost a lot. And there's also a carbide scriber here with a retractable sort of biro type end. This is for really hard materials. Wouldn't worry about that too much until you get into it, but I thought I'd just show you that so that you know it exists. Now, in reality, it's quite difficult to draw a perfectly straight line on anything, piece of metal, piece of paper, whatever. So that's where all of these come in. So I've got various squares and protractors here, which will allow you to draw lines at 90 degrees, 45 degrees, or any angle you want, to be honest, anything from 0 to 180. Now, there's obviously quite a selection there. You don't need all of them. I think, to be honest, I started out with just this one. I think I bought this off the market when I was a kid, second hand, and I've had it ever since, and I use it quite regularly. It's just a 300mm rule, or 1 foot, 12 inch, with a little sliding piece. It's a bit stiff, it's a bit old. That goes through there like that, and it can be locked in place. And then there's a little piece on the back here that you can undo, and then that allows you to swivel that round. Ooh, I think it might need a little bit of oil. And it's got a little graduated scale on it from plus minus 90 or 180 degree span. So that's really handy. But the novelty of having to constantly adjust it for every angle does get a little bit annoying, because most of the time you need 90 degrees, 45 degrees, and a straight line. So that's, to be honest, where these little combination squares really come into their own. You can get them in all sorts of different sizes. This is the one I probably actually use the most, the little 6-inch one, or 150mm. You can use it to draw a 90-degree line in there, or a 45-degree line in there, or across there, however you want to set it up. They have a little spirit level on them as well that's quite handy. And then the thing that a lot of people don't notice about these is this little thing here. They tend to come with a little scribe. And that just screws in there so you don't lose it. Very versatile tool, highly recommend it. Not as accurate as the precision squares like this. Again, I'm just sort of showing you these so you know that they're there, but as a beginner I'd be looking more at something like that, or if you just wanted one or can't afford to have both, then something like that. These are a little bit more expensive because they give you a more range of angles. These are a little bit cheaper, but again you get all different sizes. The benefit of these over these, obviously with that you get the angles, but the big benefit here is you also get a steel rule. So you've got a nice graduated scale. This one's 16 inch or 400mm, just over 400mm, or 6 inch, whatever size you like. Okay, so I've got a little piece of 1mm thick aluminium here, and let's have a go at putting some of these tools into practice. We'll start by just kind of roughly working out where I want my lines. I'll put some marks on here, just kind of ballparking things in at the moment. Right, colour that in. Okay, now they're dry, we can use the square to mark out our lines. So we'll just pop a little mark on there, use the scriber, just scratch a little line into the base metal. Just pop that on there like that. Use the 90-degree piece. Okay, and then we can just scratch that line into the ink. And then I want a line, so that's 100mm from that edge. I want a line at 50mm from that edge, so I'll just set this to 50mm. Pop that on there. So not exact for this. That's a little mark there. And we'll just scratch that line down as well. And then I want to go 50mm up. That's there. And then we want a line all the way across the top of there. There we go. There we go. Right. So you can see by colouring in the piece of metal first with the marker pen, you get a lot more contrast and it's a lot easier to see the lines. Now let's just say we wanted to put a hole or something in the centre of this, so we want to mark the centre of these squares. So we'll just colour that area in there, and because they're squares, we've been using the 90-degree bit of this, we could use the 45-degree piece now and go corner to corner. There we go, there, and there. And that's using the 45-degree, and that's now got a hole nice and in the centre of the part. Okay, so we can do straight lines and straight lines at various angles. What about if we want to do a circle or a radius? Well, that's where this little fella comes in. You remember in maths class when you were a kid and you had to draw the circles with a compass? Well, this is exactly the same, but for metal. Now with this, you can set the distance using, say, your steel rule. You can just measure off there, pinch it together, loosen to make it wider, tighten to make it smaller, and then pop it on your surface and draw your circle or your arc or your radius, whatever you want to call it. Now with these, they do have a habit of skidding around a little bit if you haven't got the knack yet. They do take a little bit of practice. So you might want to use a centre punch to make a little dimple for one end to sit in so that it doesn't skid around as you're drawing your arc. So that brings us on to the last of the marking out tools, which is the centre punches. I've got two types here. We've got a manual centre punch that you need to use with the hammer, or an automatic centre punch which is spring loaded. Now it doesn't really matter which one you use, this is entirely personal preference. If you've already got a hammer, then these are cheaper, might be a good call. If you haven't, then I'd get a hammer actually, to be honest, because you probably need one of those as well. These are good. just depends what you like. The nice thing about these is you can adjust the amount of force by twisting the top here. It'll either make a big dimple or a little dimple, or you can adjust it for how hard the piece of material that you're punching into is. The downside is if you forget to adjust it, you end up with the wrong size dimple, whereas with that you just swing the hammer harder or less hard. You'll also need the centre punch for if you want to drill holes, because the drill bit will naturally want to skid across the surface of the piece of metal. Wood, it's a bit more forgiving, the drill bit tends to just bite in. Metal, the drill bit will slide around, so using the centre punch will make you that little dimple and give your drill bit something to start in. So we can use the centre punch to put a little dimple on those crosses. This one's nice and easy, just line it up and a little tap with the hammer. Not the best aim in the world, but close enough. And then this one, like I was saying earlier, we can adjust the amount of pressure it makes. So with this particular one, if you screw it all the way in, it makes a really light centre pop. I've actually got one that looks basically exactly the same in the cupboard that's the opposite way around. So that's a really tiny centre mark, you can't really see that at all. And then if we wind it all the way out, and just line it back up again. A bit more effort required now. That puts in a much larger centre pop. So let's just use the divider, use that little centre mark that we've made, and we're going to scribe an arc onto here, because let's just say we want this piece to have a curved top. That's just going to go like that. There we go, just like using a normal compass for paper. Now we're going to need something to hold our piece of material while we're cutting it, and I cannot recommend highly enough getting a decent quality bench vise. These are, to be honest, they're not cheap. If you can't afford a new one, buy a second-hand one. If you are going to buy a second-hand one, the thing to look for is the quality of the movement, and obviously check that there's no cracks and things like that in it. But as you're opening and closing it, I don't know if you can see it on the camera, but this one does have ever such a slight wiggle in the back here. Anything more than that and I'd be looking at walking away. That's fairly acceptable. And what that is, it's the screw that goes in the middle that winds it back and forward. It's got a little bit of a curve in it. The curve in the screw is a sign that the vise has been overloaded. Okay, and when you overload the vise, it bends the screw. So if it's got a big wobble, or if it goes clunk, 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 walk away. Check it for cracks. Check that it runs nice and straight, it's nice and quiet. It's something that you'll use every single time you come in the workshop. You can get different jaws, you can get soft jaws for if you don't want to mark your piece of material, they just clip on, or you can get smooth jaws that screw in. This is a 4.5 inch vise, it's a record number 4, made in the UK, solid cast thing, absolutely brilliant. You find them in basically every workshop around the UK, they're kind of unanimous. You can get ones with swivel bases, they're really handy. To be honest, I could kind of do with one in here, because if I put something long in here, it bashes into the wall. Whereas if I could rotate it, I could poke it out through the door. But yeah, engineer's vise, machinist's vise, something like that, fairly heavy duty, it'll last you forever, buy a good one. I'd also look at getting a few basic G-clamps. Now that's what we call them here in the UK. I think in the States you guys call them C-clamps, I'm not sure about that. But G, C, you know, that looks like a C, or if you include that bit it looks like a G. Either way, they're really useful in combination with bench vise, particularly for things like holding two pieces together, or if you want to hold one piece still while you're drilling a hole in it, which is particularly useful if you haven't got things like a pillar drill, and we'll get into drilling holes in a second, but really, really useful, come in all sorts of different sizes. So a selection of small G-clamps or C-clamps, very, very useful things to have. So if we've marked out our piece of metal with our layout lines, the next thing we might want to do is cut a shape out of it. Now, if you're working in thin material like sheet aluminium or tin, you know, a millimetre or so thick, then things like this, tin snips or aviation shears, they are absolutely fantastic. They come in sort of 3 main varieties: straight cut, left cut and right cut. The name pretty much tells you how they work, but in reality a straight cut will do left and right curve, but they're a little bit more tricky. If you can only afford one, get a straight. If you can afford a set and you're going to be doing thin sheet metal work, then all 3, yeah, it does make your life easier. Let's have a go at cutting this out, shall we? We'll just use the straight cut shears because it's only a little bit of thin aluminium. So just line it up and they cut just like scissors. It's much easier if you keep the piece of metal close to the pivot point, just like cutting thick cardboard with a pair of scissors. And then just work your way along and just, that's it, and snip. You'll find that the further you get into the piece of metal, the more you have to bend this little bit out of the way. Okay, so that's one way. And then this one will be a little bit more difficult because it's got to cut a little bit further, but that's alright. Just take your time. Make sure you don't get your fingers caught in the blade. And it does have a habit of trying to bend the piece of metal up, so it's just something that you have to deal with afterwards normally. But yeah, it's just like a nice pair of scissors, nice and steady. There we go. So that's there, and then we can cut along our other line and then we'll get 2 pieces. So you can see how it's slightly deformed the part. That's okay, you can just tap that flat with a little hammer, and then we'll just trim around our radius that we drew on with the dividers. If you haven't got a left cut set of shears, or a right cut, depending on which way you're going, what you can do is just kind of nibble your way around like this, and then you just smooth it off afterwards. Okay, or you can try, doesn't always go well. You can come around like that. Try and stay outside the line, and then you can always bring it back in with a file afterwards. If you see yourself cutting thicker material, you know, a couple of millimeters thick, or cutting bar and things like that, you're going to be wanting to look at things like hacksaws. Junior hacksaw, wouldn't worry too much about it. It's handy if you're in little tight spaces, quite good for doing little bits of DIY and cutting awkward things, but not all that useful in the workshop, to be honest. This is my go-to. I've got a couple of these and I hang them up by the vise with a couple of different blades on them. It's a 12-inch 300mm hacksaw, and you can get different blades with different TPI, that's teeth per inch. It's basically the amount of teeth per inch of blade, or per 25mm. Now, this is important because depending on what material you're cutting and how thick the material is, that determines how many TPI you want on the blade. The thinner the material, the more teeth per inch you want, because that means that the piece of material doesn't drop down between the teeth so much, and it doesn't bounce the saw along as you're going. So you're getting more teeth in contact with the piece of material as it's going back and forwards. On a thick piece of material, you want less teeth per inch, and you'll be removing material at a faster rate, but obviously you're still not really sawing any quicker because the material itself is thicker. Now, with a hacksaw, the blade goes in with the teeth pointing forwards, so it's a push to cut saw. Okay, and you'll hold it pretty much like that and just go back and forwards on your line. Try and use the full length of the blade. If you just work in the middle, it's nowhere near as efficient, and it takes you a lot longer to do the job. The blade sits on these little pegs, and you can adjust the tension to make sure that it's nice and tight, and that allows you to change the blade. And you've got a second set of pegs on this side at 45 degrees, so you can put the blade on there, and if you're cutting and the depth of your cut, you've hit this bit of frame, you can put it on there, lay it over, and your piece of material will go out through this hole, and it allows you to cut slightly more awkward pieces. So we've cut out our piece of material with our hacksaw, let's say, and it will have inevitably left a rough edge. So the next thing we need to do is probably smooth that edge down, and also probably still slightly oversize, bring our piece down to its final dimensions. To do that, the most common tool you're going to use is a file. Not remotely exciting, but probably one of the most used tools in the workshop. Now, they come in all sorts of different sizes and flavours. You don't need all of them. In reality, you only need about 3. But I'll just take you through a couple of the things just so you know. So the first thing is, like we've said already, they come in all sorts of different shapes. So you can get flat ones, you can get round ones, you can get half round ones, square ones, triangular ones, ones that are pointy, ones that are constant breadth all the way down the blade, like that one. All sorts of different shapes and sizes. And then the other thing to consider is how coarse the file is. So you can get ones that are very coarse, like this, or you can get ones that are very smooth, like this, and there's a whole range in between. The coarser it is, the faster it will move material. The smoother it is, the nicer the surface finish you're going to get. And there's a couple of different techniques for the way that you use the file, which will also affect that surface finish. Now, for the beginner, I would personally recommend just getting a basic set of a flat, a round, and a half round, probably in something like second cut, which is the coarseness. It pretty much covers most of the bases, and then you can expand your set or your collection from there. But for the beginner, flat, round, half round gets you through most situations. If you can, I'd look at getting one that's got what's known as a safety edge on the flat file. So if you look at this one, it's got teeth down both sides, so that doesn't have a safety edge. This one, however, teeth on one side, but no teeth on the other. And what that means is that if you're filing up against an edge, up against a shoulder, you can file up against that safe edge, and that edge isn't going to cut into the side of the piece of material. It's only going to cut on this bottom face, or the top face if you're working upside down. So that's a really good feature to look for. Not essential, but it does make things a little bit easier in certain circumstances. The other thing you might want is a file card or a wire brush. This is just to help you keep your files clean. When you're working with particularly soft materials, the teeth on the file, they do get gummed up, and having a little wire brush or a file card, just go over them, and that just cleans it out and prolongs the life of your file and makes your cutting action more efficient. Okay, let's get those edges smoothed down. So we'll put it in the vise. Okay, now with the file, what you want to try and do is work at sort of a 45-degree angle, and you want to be going across the part and along the part at the same time. And you try and work the whole length of the part and use as much of the file as you can. If you just kind of hack back and forwards, you generally just make a bit of a mess, to be honest. So this is a nice way to get a nice smooth cut. So that's a nice general filing technique. Okay, try not to rock it back and forwards too much, otherwise you'll end up rounding the corners off, unless that's what you want, of course. And then what you'll find is that will leave lines in the part going that way, sort of 45 degrees. Then there's another technique called draw filing, where you hold the file like this and you run back and forwards, and that'll leave you with a much nicer surface finish. Okay, nice light pressure, run back and forwards. Just be careful if you're going right to the ends that you don't go knock too much off the end. So use your square to just check every so often that you're square, or work to your line that you've drawn with your scribe. With the part that's radiused, we're going to use a slightly different technique. We'll hold it in the vise just like before, but instead of going across the part, we're going to go with the part. Okay. Now, instinctively, you kind of think you want to go this way. That's actually not necessarily the best way to do it. It'll work, but you'll find that it's easier, once you've got the hang of it, to start here and then rock the file up away from the curve. Okay, so like this. It takes a little bit of practice, but once you've got the hang of it, you end up with a much nicer finish. If you take your time, you'll end up with a part with a nice constant radius all the way around. Now, you might notice we've got all these little burrs on the edge here, and the file will help us get rid of those as well. We'll just put the file on edge, and we can just run around. Ideally you want this clamped, but I'll just hold it like this so you can see. Okay, and just run around with the file on edge. You see how I'm really choked up on the file here? I'm not using the handle. I'm going right down on the blade, and I can just clean the part up, get rid of those sharp edges, and that's lovely and smooth now. Flip it over and do the other side. We probably want to put some holes in our piece of metal, and for starters, having a pillar drill and things like that, it's a lovely thing to have, but initially it's probably a bit of a stretch. So I would recommend a combi drill. Cordless is really handy, you can use it for DIY and things then. I quite like versatility, and these are really versatile, so something like that. Doesn't have to be DeWalt, you know, I like this one because it fits my hand, to be honest, and it works well. My friend Nick, he likes Makita because he's got little pixie fingers and their grips are a little bit smaller. And I've got some other friends who like Milwaukee, but to be honest I find they're a little bit heavy. So personal preference, go down the shop, get your hand on it, see how it feels. I'm not recommending any particular brand, but that's the one I use. What's probably more important actually is the drill bits. Get yourself a good quality set of drill bits. This is a metric set, 1 to 10mm in 0.5mm steps. You could go to 0.1 steps, but it's not really necessary. And then there's lots of imperial sets as well if you're over in the US. This one's also got a few special sizes in the top for the standard metric threads, or some of the standard metric threads. But the key thing to look for here for metalwork is you want HSS drill bits. That's high speed steel. And you can see it on the adverts when you buy them, or when you pick one up, they have the size and they have HSS stamped on the bottom of the drill bit. Now you can also get HSS-CO, which is high-speed steel cobalt, which is for drilling harder materials, and you can get HSS-TIN, which is titanium nitride or something like that, or titanium nitrile. They're the ones with like the little gold tips. The key thing is high-speed steel. You don't just want normal carbon steel drill bits. They don't hold their edge long enough when you're cutting metal, whereas these, they'll just keep going, and when they do go dull, you just resharpen them on a bench grinder. But that's, again, something to think about when you're a little bit further down the line of metalwork. So high-speed steel drill bits, combi drill, it's a nice combination, nice and versatile, it'll get you going. So we've already got our two little centre pops in the centre of each part, and we could drill each one of these individually if we wanted to, but just to save time, what we'll do is pop the two together and then clamp them down to this piece of wood. Okay, because what we don't want to do is drill a hole in this nice metal worktop. So having a little sacrificial piece of wood underneath just means that we won't damage the table. So we can use the G clamp for that, or the C clamp if you're in the States, and then we'll grab the drill and a drill bit and put a little hole through the centre of there. I'm just going to line up the drill bit in my centre mark, nice and gently, nice and slowly to start with, to make sure that it picks up on the centre. That looks good. And then we'll just build the speed up and then go through until we get to the piece of wood. There we go. Nice hole all the way through both pieces in the centre. So if we wanted to join them together, for example, we could put something through that hole. Now, just like when we cut the metal earlier, we ended up with the sharp edge, the burr on the outside. When we drill the hole, you get exactly the same problem. You get a little sharp edge, particularly right on the back, hopefully you can see that, where the metal sort of tears through. That's just another burr. You can get rid of that by grabbing a bigger drill bit and your part and just lightly twisting the drill bit in the hole. There are special deburring tools and things like that, but to help get you started, just grab a bigger drill bit from your set and clean the hole up with the drill bit. You want to make sure that all your parts are nicely deburred with Metalwork, because nobody wants to catch a finger on a sharp edge and cut themselves. And there are also structural reasons for getting rid of the sharp edges, particularly if you start bending aluminium and things like that. If you leave the burrs on the edges, it will cause the part to crack when you bend it. So always deburr your parts. So we've almost finished our assembly. We've got some holes to join some bits together, and what I'm going to use are some pop rivets. Now obviously you can use nuts and bolts as well. You can drill the hole, so a nut and bolt is perfectly reasonable. I think pop rivets as a permanent fixture are absolutely fantastic. I built pretty much everything using these as a kid, and they use them for cars and aeroplanes and all sorts of things. They're really handy. They come in all sorts of different sizes, and the tool comes with little adapters to go on the end there, so you can have different size mandrels. This bit here is called the mandrel, and this is a 4x10, so it's 4mm diameter, 10mm long, which is 532 by 3/8. I think that's a good general purpose size. I've just buy these in boxes of 500. You can get all sorts of sizes. It very much depends on what it is you're wanting to use. The bigger the pop rivet, the more effort you need to put into the tool to get it to go down. You can get them in different materials as well, aluminium, steel, stainless, etc. But they're really handy. I'd highly recommend those, and I'll just show you how they work. So I've got both the pieces held together in the vise with the hole lined up, and we're going to put a pop rivet through there and do it up. There we go, and that's our part held together. Well, the other thing you have to consider with pop rivets is what's known as the grip length. So they have a minimum and a maximum thickness that they can clamp on and actually perform correctly. So for these, for instance, it's 1.2 to 6.4mm. So that's your stack height of all your pieces of material that you want to put your rivet through to hold together. That's, what's that, 3/64 to about 1/4 inch. So quite a decent range of thickness there for holding sheet metal together. Now, obviously this doesn't serve any real world purpose, but hopefully it's introduced a few of the tools and techniques that a metalworking beginner might be interested in knowing about. If there are any other techniques or tools that you'd be interested in learning about, or you want me to go into a little bit more detail on any of those particular techniques that we've used, then let me know in the comments below, and I'll see about doing a more detailed video on particular aspects. In the meantime, I hope you find this useful and it helps you with some of your own projects, and I'll see you next time. Thanks for watching.